Hello, I am Ciprian Begu, a student of Vedic philosophy. I'm here with Ashish Dalela, author of many books on Vedic philosophy. In this episode of our Shabda podcast, I'll be asking Ashish more questions about the ideas in his books. Hi, Ashish.
Hello. Thank you for doing this, and I'm happy to answer your questions.
Let's start. You talk a lot about hierarchical space and time, which you describe as an inverted tree. How did you arrive at this idea, and what are the intuitions behind it?
Well, there are both scientific and religious reasons for describing the world as an inverted tree. The basic insight comes from the Bhagavad Gita, where the world is described as such an inverted tree. There are many other analogies used to describe the same idea. For example, in the Srimad Bhagavatam, the same idea is described as a reservoir of water which gives rise to rivers and rivulets. In other religions too, there is a mystical tradition which speaks about a tree. Both in Christianity and Judaism, there are references to this tree. It is also interesting that this inverted tree has a shape very similar to the Christmas tree, except that the roots are upwards. The tree has a central trunk from which many branches, twigs, and leaves emanate at successive levels. Universe is just like this Christmas tree, and the planets are just like colorful globes used to decorate the Christmas tree. So there may be a basis in history as to why this particular tree was chosen to mark the occasion of Christmas. Srila Prabhupada also spoke extensively about this inverted tree. For example, in his letter to the PhDs in ISKCON regarding the study of Vedic cosmology, he says that my final decision is that the universe is just like an inverted tree. Now, if you know the history of the study of Vedic cosmology and Prabhupada's efforts, there are many twists and turns. For some time, Prabhupada wanted his disciples to work on it. Then, looking at the hardship they were facing, he approved the engagement of an external expert in this study. When that expert also came up blank, then Prabhupada entrusted this work to his PhDs. So given these twists and turns, Prabhupada spent a lot of time going over this material. And this is what he means when he says my final decision, because he went through a lot of twists and turns and arrived at the conclusion that the best way to study cosmology is to describe it as an inverted tree. So there is a considerable background on this idea of inverted tree, and that forms the basis on which I initially got interested in this idea. Later on, of course, I have developed scientific reasons to accept this idea and described what we mean by this inverted tree and how it is very useful in science. So there's a scriptural precedence, there's this emphasis by learned masters, and then reasoning and empirical evidence. So it is not just one reason, but several independent but mutually affirming and consolidated reasons.
Yes, your books on cosmology, both Mystic Universe and Cosmic Theogony, talk a lot about the inverted tree. You also briefly talked about scientific reasons for accepting this idea. What are those reasons, and why are these reasons absent from modern science?
Well, the notion of a tree is not entirely absent from modern science. Take, for example, the tree of life drawn by biologists. They suppose that there is some primitive primordial form of life from which successive forms of lives are manifest. The tree of life in biology's attempt to capture the emergence of complex forms of life from simpler forms. Generally in science, simple means small. So the primordial life forms are the virus and bacteria, and more complex life forms emerge from these virus and bacteria. The problem with these ways of constructing the tree is that they are not capable of accommodating meanings. Because when we study meaning, the notion of simplicity is inverted. For example, a mammal is a simpler idea as compared to a dog. There are many kinds of mammals, but all the mammals have breastfeeding as a common trait, which forms the basis of calling something mammal. Now, the simple idea is modified in many ways in dogs, cats, horses, cows, and so on, which means that the understanding of mammal requires only a few words, but the description of dog needs more words. So from a physical standpoint, we say that small is simple, but from a semantic standpoint, we say that the big is simple. In this case, for example, the idea of mammal is simpler than the idea of a dog, because to describe the dog, we must say it's a quadruped mammal. So we are adding the trait of quadruped, which is increase in complexity. The idea of a dog includes the idea of a mammal, but it includes more properties. In that sense, semantically speaking, a mammal is simple and the dog is complex. So based on this, we can construct the tree of life in a new way, in which the simplest life forms are the simplest ideas, and more complex life forms are created by modifying those simple ideas. In this case, there is an original mammal who gives rise to many forms of individual mammals. The idea mammal, however, always also contains a huge number of animals. So while the idea is very simple, this simplicity is the very reason it is able to encompass a number of diverse species of life. So the simple need not be small. Physically speaking, the simple is small, but semantically speaking, the simplest is also the biggest. Now we can talk about the inverted tree in a new way, in which the root is simple but biggest, and the trunks, the branches, the twigs, and the leaves are more complex, but they are smaller. The tree is constructed from simple to complex, and from the biggest to the smallest. Since it is constructed from simplest to most complex, we can call this tree a scientific paradigm in which we build complex structures from simple ideas. However, since the simplest is also the biggest, we can say that we are trying to divide the biggest into smaller parts. For example, the biggest is the superset and the smaller is the subset. So it is somewhat incorrect to say that the idea of tree is missing from science. It is more correct to say that modern science constructs this tree in a physical manner, whereas we construct it semantically. To construct the inverted tree semantically, we have to study reality as ideas rather than things. If the original thing is physically the smallest, then the most complex thing will be physically the biggest. But if the simplest thing is the simplest idea, then the simple thing encompasses everything, and it is hence the biggest. So the inverted tree has two approaches, physical and semantic. In modern science, the physical approach is used, and I'm using the semantic approach to defining the inverted tree.
Yes, this idea about the simplest being the largest is so pervasive around us. But it's so hard to understand because science regards the simplest to be the smallest. What is the origin of the scientific view of simplicity, and why has science not used a semantic approach so far?
Modern science is reductionist, which means that big things are reducible to the small things. When we carry out reduction, we also suppose that the entities to which the world is reduced must be more fundamental. Since the big reduces to small in a physical sense, the reductionist supposes that the small must be the more fundamental reality from which the complex reality is created by aggregation. Of course, there are no a priori reasons why we cannot treat the largest as the simplest. As we talked about earlier, our everyday words use abstract and contingent meanings, and the abstract is simpler, from which the contingent is produced by adding complexity. For example, a dog is a quadruped mammal, which means you need quadruped to modify mammal, and therefore dog is more complex than mammal. So in a sense, there is a common sense view of the inverted tree in which the simplest is the biggest, and there is a scientific view of the inverted tree in which the simplest is the smallest. The scientific view is also called reductionism, and the common sense view can be called semanticism or anti-reductionism. What we don't commonly realize is that everyday language is abounding in the semantic variation of the inverted tree, while the scientific language is completely relying on the physical variation. Therefore, there is a more general conflict between scientific and everyday languages, or that between science and common sense. If nature were described according to the common sense view of the inverted tree, then it would also be semantic. So my key point throughout my work is that this common sense inverted tree must be treated scientifically, and it must replace the modern scientific tree. This is a far more sophisticated argument against reductionism because our minds naturally think in terms of the semantic inverted tree rather than the physical inverted tree. Science has gone completely against common sense in adopting reductionism, and that's a mistake I think we should correct.
So basically, you are saying that the semantic inverted tree is not a new idea, but actually the common sense idea that everybody already uses, right? And also that reductionism is going against common sense, and there is a new type of science that can be built using the anti-reductionist common sense view. If so, how different will this science be?
Well, when you look at a dog and say that it is a mammal, there is a sense in which the idea of a mammal has incarnated inside the dog. The mammal is the whole thing, the bigger idea, and it is present inside each dog. So when we take the common sense view, there is a new property which emerges, and that property is that the whole is present inside each part. This idea is noted in Vedic philosophy, wherein Paramatma or God is present in each individual thing, including the dog and the dog eater. The Paramatma is the biggest idea, and this big idea is present in every small thing, including the smallest atoms, just like the big idea mammal is present in each dog. Similarly, the demigods are said to be present within the body. Now, if you think of this idea in a physical sense, it becomes very hard to understand how God can exist inside the atom, or how demigods can exist inside each body. But when we treat the inverted tree semantically rather than physically, this idea becomes very easy to comprehend. During Greek times, Aristotle formulated the distinction between form and substance. For example, a dog is the substance and the mammal is the form inside each dog. Over time, as scientific understanding was revised to adopt a physical approach, forms disappeared from science and we were only left with substance. In modern science, however, form reappears as mathematics, and mathematical laws are present inside each thing as the governing rules of behavior. Scientists have struggled a lot to describe how mathematics appears in the physical world. As Eugene Wigner said, this constitutes the quote-unquote, the unreasonable effectiveness of mathematics within science. However, this problem arises only in the physical inverted tree and not in the semantic inverted tree. The mathematical laws are the abstract ideas which appear inside each individual thing, just like mammal is inside each dog. So whether we approach the problem from the perspective of modern science, where mathematics becomes the form inside substance, or from philosophy where form advents or incarnates inside each thing, there are intuitive grounds on which this notion can be understood. In Vedic philosophy, the Paramatma and the demigods are higher level ideas that advent into each object. This gives rise to an apparent paradox in which small things are inside big things due to physical reduction, and the big things are inside small things due to semantic expansion. In modern science, we are only able to accept that the small is inside the big, but not accept how the big is inside the small. To answer a question how this new approach will be different from the current one, the short answer is that the current approach allows small inside big, and the new approach will also allow the big inside the small. The new approach to small and big changes the nature of space from being a box to being a fractal structure, which has to be described like a tree. In a fractal, the big is inside the small, and the small is inside the big. So when this paradigm is understood properly, we must revise the nature of space and time, and then as a natural consequence, the understanding of matter as well. Therefore, what I mean by the tree is that space, time, and matter are like fractals. The big is expanding into small by adding more attributes to the big. For example, mammal is becoming dog by adding the attributes of tail and quadruped. And the big is incarnating inside each small thing for the very same reason, namely that the dog semantically includes a mammal but doesn't physically include it. So we can see a mammal in each dog, but the mammal is not a dog. This is due to conceptual hierarchy. This is the general paradigm under which we can resolve many scientific paradoxes. It is also the basis of the Vedic philosophical stance called Achintya Bheda Bhed Tattva, in which the small is inside the big and the big is inside the small. Difference is that the small is inside the big physically, while the big is inside the small semantically. So there is actually no paradox or contradiction involved. But by adopting the common sense view, we take all that modern science gives us and then go beyond it.
Wow. This idea about the big inside the small is both interesting and also perplexing. So the big exists inside the small as the form in the substance. And it seems that the form exists outside the things, and yet it incarnates inside each thing. Are there philosophical precedents in the West for accepting this type of an idea?
Well, in Platonism, there is a form outside the substance, and this separation between form and substance is described as two separate worlds. There is the Platonic world of pure ideas, and there's this material world in which the ideas incarnate. In Aristotelian philosophy, the form and substance are in the same thing. So in effect, there isn't another world apart from the material world, like in Plato's philosophy. Greeks chose either of these two alternatives rather than both. So either the form is inside the thing, or it is in another world. They could not accommodate both these ideas, so eventually the existence of form was rejected because it was not contributing to the idea of substance. For instance, if the form is existing inside the substance, then why do I need to give importance to form rather than just study the substance? It makes sense to give importance to form only if it exists both inside things and outside of those things. Unfortunately, Greek philosophers were never able to make this transition, and hence practically all of Western philosophy went against common sense in rejecting the existence of forms. In Cartesian metaphysics, form was supposed to reside in the mind, while the body was the substance. Again, we could not say that the mind is inside the body and the body is inside the mind. This led to the mind-body duality that we are all familiar with, because mind and body become two different substances which are separate from each other rather than inside of each other. The main problem has been that Western philosophers have been unable to grasp the true nature of common sense, in which the big and the small are inside each other. So I don't think there is a good precedent in Western philosophy to handle this problem. Greeks came close by acknowledging form and substance, but they could not make the complete leap.
It's interesting you mention mind-body dualism in this context. Is the mind inside the body? I ask this because most materialists reduce the mind to the body.
Yes, the mind is inside the body in the same sense that mammal is inside the dog. We must remember that the mind is not physically inside the body, but it is semantically inside the body. In this regard, we can understand the use of what is called the Shakachandra Nyaya by Lord Chaitanya. In ancient Indian philosophy, examples by which we can rethink the nature of reality were called Nyaya. The Shakachandra Nyaya says that the moon is in between the branches of the tree. Factually, the moon is somewhere else, but you can also say that the moon is in between the tree branches. Like that the mind is within the bounds of the body, just like moon is within the branches of the tree. This basically means that you can detect the presence and effects of the mind within the body, but the mind is not physically inside the body. Just because you see the moon in between the branches of the tree doesn't mean that the moon is physically there. So you can carry out experiments on the body and you will find that there is a mind, as you can perceive the effects of the mind on the body. But it would be a mistake to reduce the mind to the body, just like it would be wrong to say that because I can see the moon in between the tree branches, so it must actually be physically inside the tree. The reductionist and materialist philosophers are victims of the Shaka Chandra Nyaya. They insist that just because I can detect the presence of the mind in the body, therefore the mind must be the body. This reduction is tantamount to saying that just because each dog is a mammal, therefore mammal must be the dog. In other words, there is nothing more to the word mammal than all the breastfeeding animals, so mammal itself is not an idea that exists apart from these animals. The fact is that the mammal is inside the dog, and yet it is outside the dog. And you need a new notion of space to understand this inside and outside. That notion of space is the semantic tree of ideas. Likewise, the mind is inside the body by its effects, but factually the mind is outside the body. This only means that the existence of the mind can be detected through bodily behavior, but the mind doesn't reduce to that behavior. This idea is pertinent to understanding how the soul is inside the body and yet not the body. Factually, the soul is like the moon, situated somewhere else. But the soul casts a reflection in the body by which we can say that the moon has appeared between the branches of the tree. So you could say that the soul is inside the body, just like the moon is in the branches of the tree. But as Lord Krishna explains, if the body is burned, the soul is not burnt. So if you cut down the tree, the moon will no longer appear within the branches, but the moon will still exist because it was always outside the branches. Modern science has been defined to study the tree rather than the moon. When we observe the tree branches, we can see the moon inside. But since the moon can be seen even when the branches are cut, therefore, the moon is not inside the branches, although it appears to be there. This idea is deeply connected to the problem of reincarnation of the soul, where the soul goes from one body to another and becomes entangled in the body, just like moon can be seen through several branches of several different trees. And yet you can keep investigating in the body and never find the soul. By chopping the trees, we cannot cut down the moon. It only means that the existence of the soul is like that of the idea of mammal, which exists inside each dog, and yet it doesn't reduce to the dog itself.
You initially said that God is inside the body, and now you are saying that the soul is also inside the body. And yet, by destroying the body, we don't destroy neither of these. And all this follows simply from adopting the commonsensical view on the inverted tree.
Yes, the presence of the soul and God is empirical within science. But that empiricism doesn't mean the soul and God are material. We can epistemologically confirm the existence of the soul and God inside the body by formulating the theories of nature that employ soul and God. And these theories will be confirmed because the soul and God have effects on the body which cannot be explained without the hypothesis of the soul and God. But the soul and God are not ontologically reduced to the body. So you can epistemologically confirm the existence of the soul and God in matter, but you cannot reduce them to matter. This is a different kind of empiricism which is non-material. In this empiricism, soul and God are ideas or concepts whose presence can be detected inside matter, but these are not reduced to matter. In classical Western empiricism, which is also material, if you can see something empirically, then it must also be material. It is a subtle fact about modern science that we actually do not perceive the scientific concepts such as mass, charge, energy, angular momentum, spin, etc. What we perceive is just taste, touch, smell, sound, and sight. But we explain these perceptions by using a host of scientific concepts such as particle, wave, mass, energy, momentum, etc. So even in scientific empiricism, the theoretical ideas are not directly measured. For example, you cannot just talk about a particle or mass. You have to measure their effect in terms of motion. If the theory that uses these ideas makes correct predictions and explanations, we say that those ideas in the theory have become real. So we are within the bounds of the empirical method when we say that soul and God are ideas which have effects on the body. And while we cannot observe these ideas, we can measure their effects. These ideas must be given reality through the confirmation in the same way that particle, wave, energy, momentum are given reality after the theory using them makes correct predictions. So semanticism doesn't overturn the empirical method, but it helps us understand why it works so well. The reason is that ideas such as mass, charge, energy, momentum, etc. incarnate in each object, just like a mammal incarnates inside a dog. By this incarnation, we say that there are many individual mammals which must behave according to the theory about the mammal. We never perceive the mammal by our senses, but we can see the individual dogs. However, these dogs follow the rules of being a mammal. In the same way, we never perceive mass, charge, energy, or momentum, but we can see that each individual thing follows the laws prescribed to these conceptual properties and objects. When the theory is empirically confirmed, within the theory we can understand concepts. Just like you can say the moon is within the branches of the tree, but the moon is actually not within the tree.
Okay, so I can see now how the semantic view of the inverted tree, as opposed to the physical view of the inverted tree, allows us to treat soul and God as scientific concepts without reducing soul and God to material objects. But how does this transform our understanding of matter? Do we simply add deeper ideas like soul and God to matter, and science continues the same way? Or are we talking about a more profound change?
Of course, we are talking about something more profound. We are saying that every material object embodies a hierarchy of ideas, and with every such idea comes a law of behavior. Therefore, the laws of behavior are different for a tree and an animal, and the greater the number of ideas involved in the hierarchy, the greater is the number of associated laws. This means that there is no universal law of nature. Rather, laws are tied to concepts. Just like in Newtonian physics, the Newton's laws of gravity are tied to the particles, but the Newton's laws don't apply to waves. Similarly, if there is more conceptual refinement, for example, a tailed quadruped mammal, then there are more associated laws because there are more concepts. Therefore, before you can even apply laws, you have to know the conceptual hierarchy or how many such laws are required in each case. The law associated with the concept is universal in the sense that it is independent of the individual objects. But not every concept is present in every object. It is only when a concept is present in an object that the law applies. Now that doesn't mean the concept and the law are false. In some contexts, the laws will be applicable. But if the concept is not present in the object, then the law is not applicable. Ultimately, it entails the contextualized application of natural laws. Some objects therefore have more laws, and other objects will have lesser laws. And these laws are different for the different objects based on which concepts are applicable to each object. You cannot talk about universal laws of nature empirically, but you can say that all the laws exist at all times. Whether they apply to an object or not varies. The universal laws of nature are based on the premise that there is only one concept applicable to each object. For example, in classical Newtonian physics, that concept is a particle. Everything in the universe is a particle. But if there are multiple hierarchically organized concepts, then there are many hierarchically applicable laws. The laws, therefore, also form a tree, just like the concepts form a tree. As you traverse the conceptual hierarchy, you also find more laws applicable to that object. To know the true laws of nature, we have to traverse this hierarchy of concepts on the inverted tree, and thereby we will find all the laws applicable to a given object, which is situated on a particular part of the tree. Therefore, each object has a different behavior because it is a different type of object, and to that type of object is an associated type of law. We can build universal laws by taking ideas into account, but we must contextualize the application of these laws depending on the hierarchy of ideas present in an object. So the tree of meaning leads to a tree of laws. And this is an important shift in science because we know that all modern theories of science are incomplete. We are describing them in terms of some laws which are incomplete. And this results in the behaviors or the theories only predicting the behavior in terms of statistics or on average. But they are not able to exactly predict which behavior will be manifest when. It's eventually signifying that some of the laws which are at the lower level of the hierarchy are missing from science. The root cause of this incompleteness is that we are trying to universalize the behavior by using a single concept and a single law when we should be contextualizing the behavior by the application of a tree of concepts and associated laws. The incompleteness of science is a broader topic and we should talk about it probably another time.
So, in a nutshell, by a tree of meanings, do you mean a hierarchy of concepts and laws?
Well, along with concepts and laws, there is also the hierarchy of choices. These choices come into play when we divide the whole into parts through the hierarchy. And there are many ways of performing this division. For example, in the previous conversation, I alluded to the idea that color can be divided into either red, green, and blue, or cyan, magenta, and yellow. As we divide the higher concept into a different set of lower concepts, the concepts are changing and the associated laws are also changing. The division of the whole into parts involves choices, and as we go through the hierarchy, there is a succession of choices. So the basis of the hierarchy of laws and concepts is the hierarchy of choices, or the successive choices we make to create lower concepts by dividing the higher concept. So in a sense, there are three different kinds of hierarchical trees. The first tree deals with the hierarchy of choices or the methods of dividing. The second tree deals with the application of this method to the division of the whole into the parts. And the third tree deals with the laws associated with these concepts. These three trees are called Anand, Chit, and Sat respectively in Vedic philosophy. Anand represents the type of method used for division. When this method is applied to a concept, its parts or subsidiary concepts are produced. And each such concept has an associated lawful behavior. So ultimately, each material object and its associated laws are constructed by choices of dividing the whole into parts. This idea can be illustrated through an example. Suppose the higher level idea is a car, but it doesn't yet have a mechanism. To create the mechanism, we have to provide a design of the car, which involves dividing the car into smaller parts, and then each of the parts into yet smaller parts, and so on. Different cars can have different designs. Some might have 2 seats, others have 4. Some have greater space allocated to the engine and lesser to the storage trunk, and the seats, while other designs keep the storage small and give a lot of space to the seats and the engine. Some cars have air conditioning on the front, while others have air conditioning in the front and back, etc. To create this design of the car, we need methods of dividing the whole into the part. The car is the chit, and the division of the chit into smaller parts is due to Anand. Anand is the method by which you divide. However, we cannot create this division of the whole into parts unless we know the functions for which the car is going to be used. For example, are we building a station wagon or a sports car? Is this a truck or a sedan? So by defining the functionality, we provide restrictions on the possibilities of choices of division, but we do not exhaust the choices. These functional restrictions are Sat. The requirement to build a sedan restricts the possible choices of divisions of the car, but it doesn't completely eliminate the possible designs. As the number of restrictions and requirements increases, the possible choices reduce. In the limiting case of an exact requirement that is also very detailed, there is only one choice. This means that we can relax the requirements and restrictions and increase the freedom, or we can increase the restrictions and reduce the freedom. In the upper part of the tree, the requirements are relaxed, and hence there is more freedom. In the lower part of the tree, the freedom is gradually reduced. This idea is used in Vedic cosmology to describe the universe as an inverted tree, in which the top part of the tree affords greater freedom and lesser laws, while the lower part affords lesser freedom and more laws. So this is neither the extreme of pure choice nor pure determinism. There are restrictive requirements that limit the freedom, and then there is greater freedom with lesser restrictions. The laws of nature effectively act as restrictions on choice. These laws are like the requirements to build a car. Some designer has been given very precise requirements, leaving little room for freedom. Some other designer has been given very few requirements, allowing them greater creativity and freedom to create the car. So nature relaxes and tightens the requirements and hence the laws. Nobody is completely free of all the laws in the material nature, but it is possible to become gradually or incrementally freer of these laws. Similarly, it is possible to become more and more entangled in these laws and lose the freedom. So from here we can see that the laws of nature for each person are not universal. Rather, each person is put in a different situation, which brings along with it a different set of laws.
But how do we decide which person is going to be put into which type of situation? How do we decide which person has stringent requirements and lesser freedom, and who has lesser requirements and so greater freedom? Is there some kind of law that decides the laws?
This is a fantastic question. Yes, in Vedic philosophy, the restriction on freedom is called karma, and the law that decides whether someone gets lesser or greater restriction is called the law of karma. Karma restricts our conscious choices or desires. Those who have good karma are afforded more freedom and lesser restrictions. Those whose karma is bad are allowed lesser freedom and more restrictions. The law of karma is that your freedom comes from how you use your freedom. If you are responsible when you have been given the freedom, more freedom will arise from your actions. If you act irresponsibly, when you are given more freedom, then the freedom will shrink and create more restrictions. It's a very simple law that deals in choice and responsibility. More responsibility leads to greater freedom, and irresponsibility takes away that freedom. But we need to know what responsibility is. Responsibility is a proper subset of our freedom. If we don't have the freedom to do certain things afforded by our circumstances or our environment, then we cannot be held responsible for neglecting our duties. So there is freedom, and there is a proper subset of that freedom which constitutes our responsibility or duty. How the subset is to be identified is a more involved topic that we can talk about another time. But the basic point is that the laws of nature are contextual because they deal in lesser or higher freedoms.
It appears that simply by treating the inverted tree as semantic instead of physical, we completely change the nature of science, the understanding of matter, and the laws governing the material reality. Don't you think this is too much change for modern science to absorb? Don't you think that these fundamental changes cannot be inducted in modern science without throwing away every foundational idea, making acceptance very hard? How do you think such an approach could be made broadly acceptable?
Yes, it is true that the differences between common sense and science are too high. And these differences, as we have already talked about, are not new. They basically originated in Greek times. So the entire history of Western thought has been plagued by the problem of scientifically understanding choice, freedom, morality, and reconciling it with natural laws. Owing to this problem, we have the famous and never-ending debates about which we have to prioritize, for example, choice versus freedom, freedom versus responsibility, and so on. I do not see an easy answer to this problem other than starting from the time when the problems originally began. The journey is not easy precisely because the mistakes are so profound. When we dismantle the foundation of a large structure, the entire structure is weakened and collapses. The notion of a semantic inverted tree is that type of idea which erodes everything established in modern science, which is why it's impossible to reconcile it with modern science, materialism, reductionism, etc. But I'm also optimistic despite the difficulties because big changes have occurred in the human ideological history in the past. I'm therefore not so much concerned about the conflict with modern science as I am with articulating and explaining what the alternative is and how it works. If he can explain how the alternative works, there is simply no hope for its adoption. If he cannot explain how the alternative works, there is simply no hope for its adoption. But even if he can explain the alternative, its adoption requires a massive paradigm shift in science. Where this paradigm shift occurs, how it occurs, and when it will occur is hard to predict. But one thing is certain, if we don't adopt this shift, science will keep moving away from common sense and find itself in a greater level of conflict with human thinking. It is possible that science will succeed in its efforts and displace common sense. But the journey for science is not going to be easy either, because as you displace more and more of the common sense, you find it harder and harder to make progress over time because you no longer have the intuitions on which you can develop new ideas and understandings. Therefore, departure from common sense is not going to be an easy path for science either. It hamstrings science. On the other hand, the acceptance of the common sense view, while it might sound initially very hard, can make much faster progress over time. In the Bhagavad Gita, it is described that the path of true knowledge or sattva guna is painful in the beginning, but pleasurable in the end. The path of ignorance or tamoguna, on the other hand, is painful all throughout. The struggles of science in violating common sense will therefore make science harder and harder over time. Most scientists will not be able to provide breakthrough ideas that seem practically useful. With this hardship comes the deterioration of intellectual efforts, where people will simply focus on publishing papers that talk about minor modifications to established ideas, rather than attaining the truth by challenging the established dogmas. Science will become paralyzed with its own ideas and unable to distinguish good ideas from bad ones. Most people will slowly become disenchanted with the pursuit of knowledge and adopt an instrumental view in which incremental advances in technology will be considered more valuable than trying for ideological breakthroughs. This is the sad predicament that science faces today. It is caught between a rock and a hard place, in which it has the choice of chugging along with ever-slowing breakthroughs or throwing away the ideologies of the present time to start fresh and make rapid progress thereafter.
Thank you. It seems that science is caught in its own innovator's dilemma, where an established system will not be able to see beyond the things that made it successful in the past, to realize that what worked in the past may not always work in the future.
You put it quite well. Science needs disruptors, but it is unprepared to accept disruption from within. Especially when the disruption cuts to the foundations of modern science to establish a new foundation, it actually threatens the established programs and methods of science. And this threat invites a backlash. For this reason, science needs a more open system that can allow rapid progress in the longer run, even if it means sacrificing the ideas of the past in the shorter run. When so much is at stake, I think it's a matter of time when such a change will happen. It's not a question of if, but one of when.
This was an entertaining and informative conversation. I'd love to talk to you more about the problems in science you have alluded to. What are those issues that have been hampering the progress in science for the last several decades? And can these problems ever be overcome? But I think we have to stop now and continue this topic in our next session. Thank you.
Yes, indeed, the problem of incompleteness in science will make a useful next conversation. Thank you for listening, and it's been great talking to you.